Okay, let's keep going. Sine inverse of sine. So let's think of this as two problems. First, I'm going to find the sine of this, and you're going to get a number, and then you're going to take the sine inverse of that number, and you're going to get an angle at the end. So let's see. If I do the sine of 5 pi over 3, so this is 3 pi over 3. If I go all the way to here, that's 6 pi over 3. So I stop short 1, and I'm down here at 5 pi over 3. So I take the sine of it, but that's the same as if I would get. So what you can say is, look, you're going to get a number, right? And I really don't care what that number is. When it undoes that number, what it's going to give you back is it's going to stay in the restricted area from negative pi over 2 to pi over 2. So it can't give you back this number. What it's going to give you back is the coterminal angle, right? So instead of 5 pi over 3, we know that really we're short pi over 3 if we're going towards the axis. So the way to write this angle inside of the restricted area, because we restrict for sine inverse, would be negative pi over 3, because we go down 1 pi over 3. So this angle is going to be negative pi over 3. Right? Now, if you want to, you could have gone ahead and found that angle. So we don't have to do this, but let me just show you what it is. Well, when you take the sine of pi over 3, you know from your trig hand that if our reference angle up here is pi over 3, for sine, you're going to get the square root of 3 over 2, right? But since it's down there, it's negative. So now I'm going to take the sine inverse of negative square root of 3 over 2. Well, square root of 3 over 2 is going to give me pi over 3, but since it's negative, that's why it's negative pi over 3, yes? So again, we didn't have to find that number, but if we did, that's another way to work back to it. All right, let's do another one. So I'm going to take the tangent of 5 pi over 4. So I'm going to take the tangent of 5 pi over 4. Let's do it. So the tangent of 5 pi over 4, the tangent of 5 pi over 4 is going to give us some number. We're going to do that first, and then we're going to take the sine inverse of that to get back to an angle. So first off, I take the tangent of 5 pi over 4. So if I look here, if I go all the way to here, this is 4 pi over 4. So I go one more, and I'm right here. So if I'm right here, then that means my reference angle is pi over 4, right? So I need to make it thinner. So pi over 4 is my reference angle inside here. So when I look, my cosine is the square root of 2 over 2, and my sine is the square root of 2 over 2, which we get from trig hand. That means over here I get negative square root of 2 over 2 for my cosine, and square root of 2 over 2 for my sine. They're both negative, right? So since tangent is equal to sine over cosine, that means that the tangent 5 pi over 4 is equal to cosine of 5 pi over 4 over the, or you know what I meant, put sine. So this goes down here. It's the sine of 5 pi over 4 over the cosine. So it's going to be negative square root of 2 over 2, negative square root of 2 over 2, and you're going to get 1. So get 1, right? And then it wants to know sine inverse of 1. So now this is a completely new problem. So now I draw a completely new picture, and I'm going to restrict myself for sine inverse to over here, and I want to know, when do you get a sine inverse of 1? Well, that's the same thing as saying sine of what mystery angle gets you 1, or where is y equal to 1, and y is equal to 1 right here, right? So that must have been pi over 2. So the mystery angle that I'm looking for is pi over 2. Okay, you see how that's a two-step process? First do this, and then do this. It's a composite function. And yes, this looks like the eye of Sauron. Okay, moving on. Now, arc sine of 0 is going to give us a theta, and then we're going to take the cosine of that theta to get an answer, right, to get a number. So arc sine, I do sine inverse, and I know I restrict myself to the right-hand side. And I want to know, where does the sine of some mystery angle get you 0? Well, inside of here, that's saying that my y is 0, so it must have been right here at 0 radians. So this is really the cosine of 0 radians. And so now this is a completely new picture. If I'm looking at the unit circle and I go at 0, this is cosine sine for my xy, and the coordinates are 1, 0, so the answer is 1. Okay. Here, sine of arc tangent of 1. So if you do arc tangent of 1, you're saying, where over here do you get out a positive 1 for tangent? And that's going to be pi over 4. Because you know at pi over 4, cosine and sine are both the square root of 2 over 2 and the square root of 2 over 2. So that's why the tangent of pi over 4 is sine over cosine. So you're going to get the square root of 2 over 2 divided by the square root of 2 over 2, and that's why you get 1. So if you undo 1, you get back pi over 4, but you know that the sine of pi over 4 is just the square root of 2 over 2. So again, we did the inside to get an angle, and then we had a brand new problem. We took the sine of this, and we got square root of 2 over 2. Okay, two-step process again. First, we're going to find the cosine of this angle, and then we're going to take sine of whatever, sine inverse, excuse me, of whatever that number is that we get out of cosine. Let's come over here, and I know that negative pi over 6 is down here, that my theta reference, my reference angle is pi over 6, but from trig hand, I get that the cosine of pi over 6 is the square root of 3 over 2. So that means, look, they have the exact same x value or the exact same cosine. So this is exactly the same as the cosine of negative pi over 6. It will also be a square root of 3 over 2. So this is the cosine inverse of the square root of 3 over 2. So what you're going to get out is now a new problem. So let's see, this is a new problem. So I come over here and I have sine inverse. And down here with a y. So y is equal to square root of 3 over 2. But notice that needs to be a positive. So where do I have a positive y? Well, that's up here. So I'm looking for the angle that gives me out square root of 3 over 2 for sine. Well, on my trig hand, 1, 2, 3, 4, 5, it's cosine sine. Sine is on bottom. So where do I have the square root of 3 fingers over 2? You must have put down this finger, which is pi over 3. So the answer is pi over 3. Okay. Let's keep on going. Evaluate these, consider drawing. It even tells you to draw a triangle. So there's a big hint. Notice that this is not on trig hand. So I cannot undo that with my trig hand, so that means that I need to draw a triangle. That's really the big key. You're going to draw a triangle because if you undo 4 over 3, 4 over 3 is not on your hand unless you've broken your hand. Which if you have, I'm sorry. That's probably very painful. So let's now do, first thing we're going to do is we're going to find out about theta, and then we're going to find the sine of that theta. So this gives us information about theta. I'm going to take the sine of theta, but I know that sine is y over r. So really, it just comes down to finding y and r. So let's draw our picture. So first, if I look at theta, if I am doing tangent, this arctan of 4/3 is just saying that the tan of my mystery angle is 4/3, but guess what? Tangent is y over x. So they're either both positive or both negative, but for tan inverse, I'm restricting myself to the right-hand side. So that means I have to be in this quadrant because they're both positive. I can't be in this quadrant where they're both negative. So I have some mystery angle over here, theta, that I need to use to find the sine of theta. But when I draw my triangle, I now have that y is equal to 4, x is equal to 3, and so really my job is to find r. Because I already know that y is equal to 4, so if I find r, then I'd be done. But I know that x squared plus y squared is r squared, so you put in 3, you put in 4, and now you can find r, right? So you get that r is plus or minus 5, but you know that it's always positive, so r is 5. So x is equal to 3, y is equal to 4, r is equal to 5, because it's a 3, 4, 5 triangle. That means your answer is going to be 4/5 is what that sine is going to be. Okay, all that work I think is important. So now let's do arc cosine of 24 over 25. So that's going to give us some angle. Then we want to take the cosine of that angle. So let's go find out more about our angle. Specifically, if cosine is x over r, I need to know x and r. Well, this in yellow is just telling you that the sine of your mystery angle theta is 24 over 25, where that's r, and this is y. So I know if I do sine inverse, which is what this is, I need to restrict myself to the right-hand side. So if you want y to be equal to a positive number, it must have been up here somewhere, right? So we're going to open up our triangle like this, and our y value is 24, our r value is 25, and x is something I don't know. So we need to find x. Because I need x divided by r, if I stop now, it would be x, which I don't know, over 25. But let's find x using the Pythagorean theorem. So this is going to be 25 squared is equal to x squared plus 24 squared. So you're going to get 25 squared minus 24 squared is what x squared is. That's going to turn out to be 49. And so x is plus or minus 7. But since it's going in the positive direction, we know it's positive. So x is equal to 7, y is 24, r is 25. So if you want x over r, which is what you were asking for, it would be 7 over 25. 15, tangent inverse of some stuff. So I do tangent inverse. This is just going to tell you about an angle, and then I'm going to take the secant of that angle. But I know that secant is related to cosine, so instead of x over r, it's going to be r over x. So the tangent of some mystery theta is negative 3/5, but that's y over x, right? Well, for tangent inverse, I look here. And so I need one of those to be negative. Tangent negative 3/5. Okay, let's see. I need one of those to be negative. So I guess it could be here. Or it could be here. How do I know which one it is? So tangent inverse of negative 3/5. And I want to undo the tangent of negative 3/5. So when I think about undoing tangent, it's over here. And tangent is y over x. X is positive in both of them, so it has to be the y that's negative, right? So it has to be the y that's negative because x is positive in these two areas. Is everybody okay with that? So it must be down in this area. Okay, because it's y over x, and that's tangent. All right, so that means that y is equal to a negative 3, x is equal to 3, and x is equal to 5. X is equal to 5, and r is something I don't know. Right? Okay, so I need to find r. because as of now, I just know that x is 5. I don't know what r is. So x squared plus y squared equals r squared. X squared is 5 squared plus negative 3 squared is equal to r squared. So 25 plus 9 is equal to r squared, right? So that's what? 34, is that right? So r is going to be the square root of 34. Plus or minus, we know it's always plus. So this is the square root of 34 over 5. All right. Let's do some more. Oh, that's so interesting. We didn't do that one. Okay, so cosine inverse of a number is going to give me an angle, and then I need to find sine of that mystery angle. So this in yellow is just telling you that the cosine of my angle is negative 2/3. But if you're undoing cosine to get back to that angle, you must restrict yourself to the top. By restricting myself to the top, I know if I'm looking for an x of negative 2/3, it must have been over here. So I'm looking for this value, right? Here, it's telling you that x is equal to negative 2 and r is equal to 3. So x is equal to negative 2, r is equal to 3. I just have to find y. Sine is y over r. So as of now, I know r, but I don't know y. I don't know why. I get it? Okay, so let's find the letter y. X squared plus y squared is r squared. R squared is 3 squared. Y is what I want. And x, is negative 2. Right? I know that's confusing because it said 2/3, but just go with it. So it's negative 2. So that's 4 plus y squared is equal to 9. So y squared is 5. So that means y is plus or minus the square root of 5. In this case, it must be the plus because I'm going up. So x is equal to negative 2, y is equal to root 5, and r is equal to 3. So this is going to be root 5 over 3. Right? 17, cosine inverse of this. So this is going to tell us about a theta, and I'm going to find cosecant of that theta. Well, I know that cosecant is related to sine, but sine is y over r. This must be r over y. So now I'm going to draw a triangle. Cosine inverse spits out 2x, just means that the cosine of some mystery angle is 2x over 1. So I could think about this as being my x value, right? And this being my, what? R. So if I'm doing cosine inverse, I must restrict myself to the top. So I'm looking here, I'll assume x is positive to make my life easier. I would let you know that on the test, or just assume it. So here, if x is a positive 2x, then here's my theta, correct? So, are you done? Yeah, you can just hand me the test. Thank you. I appreciate it. So if that's my mystery theta, then x is here, is going to be 2x, and then my y I don't know, but my r is 1. So I need to find y. Because if I stop now, I know that r is 1, but I still don't know what y is. So x squared plus y squared is equal to r squared. X is 2x that gets squared plus y, I don't know, and r is 1. So that means that 4x squared plus y squared is 1. So that means that 1 minus 4x squared is what y squared is. So y is plus or minus the square root of 1 minus 4x squared. Well, is it positive or negative? Well, since this y goes up and down, it is positive. So it's 1 over the square root of 1 minus 4x squared. All right. Review. if this happens and tangent is positive, find cosine and cotangent. Well, this is very similar to what we just did, so we draw a picture. Sine, let me see, is y over r, so I know that the y must be the one that's negative. So y is equal to -7, r is equal to 8, so x is equal to I don't know, right? Let's see. It says that tangent is positive. So if y is negative, it could have been either one of these quadrants. But since this is y over x, to get a positive, either they're both positive or they're both negative. So in this case, they're going to have to both be negative. So it means I'm in this quadrant. Okay? Because it told me sine was negative, y was already negative, so it must be negative. So I'm in this quadrant. So I'm going to draw my triangle with the radius starting from the center and moving out. And then I always drop to the x-axis, no matter where I am. So there's my right triangle. So y is equal to -7, r is equal to 8, and x is equal to some negative number. Let's go find it. So I know that x squared plus y squared is r squared. So this is 8 squared is equal to -7 squared plus x squared. So this is 64. This is 49. Right? But what is 64 minus 49? That should be 15, right? 5, this is 5, 1, right? So x is going to be plus or minus the square root of 15. In this case, it is negative the square root of 15 because I want to be over here on the left-hand side. So if you ask me about cosine, I'm going to say it's x over r. So that means that I have the square root of 15 over 8. And if you ask me about cotangent, that's tangent is y over x, so cotangent is x over y. It's going to be the square root of 15 over -7. And there's your answers. All right. And I think that's that entire review. Great work, people. Now let's go on to the next one. And before I do that, I will take a break.